Hi, how is it going? Welcome to Code with Z. Today's problem is LeetCode number 26 and it's quite wordy. We have to remove duplicates from a sorted array, and as you can see, we're given this long description of what we should do that I'm gonna simplify for you. And first of all, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're given an array of numbers and it's sorted and we gotta remove duplicates from it. But we have to do this in place, meaning we can't make a new array and add the unique numbers to it. We actually have to modify the array itself in place. Now, if we scroll down a bit and check our example here, as you can see, we're given an array and we gotta remove the duplicates. And this should be our output. In our output, we're not returning the array itself, we're actually returning the number of unique numbers that exist in our array. We have 2 unique numbers in our array, so here we are returning 2. And this number here is called k. So basically k represents the number of unique numbers that exist in our array. But this question is a little bit weird because even though we only have to return k, we still have to remove the duplicates from our array. Alrighty, let's solve this together, and don't worry, I'll visualize everything and I won't finish this video until I make sure you fully understand how to solve this problem once and for all. These slides took me ages to build, but I hope it provides you with value. So as you can see, this is our array of numbers, and we gotta come up with an algorithm that's gonna return a variable called k, and this k is representing the number of unique numbers in our array. So first of all, what if this was actually an empty array? Well, if it was array, we literally don't have any unique numbers inside of our array, right? So our k is gonna be 0 because k is representing the number of unique numbers in our array, and our array is literally empty, so we have nothing. And because of that, k is gonna be 0, right? And if we have one number in our array, as you can see, our k is always gonna be 1, because if we have at least one number in our array, one number cannot have any duplicates, so the number of unique numbers in our array has to be 1. Even if we have 2 numbers in our array, the number of unique characters in our array is gonna be at least 1. Why? Because even though we have 2 zeros, one of these zeros is actually unique, so the number of unique numbers in our array is gonna be 1. So when we are given something like this, we can assume that k starts from 1, right? Because no matter how many numbers we have here, there's at least one unique number. Alrighty, so for our algorithm, we obviously need to have a loop because we have to loop through our array, right? And see if we have duplicates or not. So we're gonna have a for loop, and this for loop is gonna start from the index of 1. Why 1? If we start from the index of 0, meaning the first number in our array, this is gonna be unique no matter what because it's the first number, right? And we can't compare it to anything. It's only when we get to the second number or the number with the index of 1, we can actually start comparing it with previous numbers, right? So we can know if we have duplicates or not. So just know that our I starts from 1, and you're gonna see how all of this works in the visualization, don't worry. And then inside of our for loop, we're gonna have an if statement. We're gonna say if numbers of I, meaning the current number, is not equal to the previous number, meaning if the number is unique, add that number, this is our current number, to our array at the index of k. Again, don't worry, you're gonna see how this works in the visualization. But this here simply removes the duplicates from our array, and then we're gonna say increment k. And after our loop, we're simply gonna return our k. Now, let's visualize this together. So as you can see, we are in the first round of our for loop, right? And our I starts from 1. So the number at the index of 1 is gonna be this 0, so our I is pointing to this number here. And inside of our for loop, we're gonna ask if numbers of I, meaning this 0 here, is not equal to numbers of I minus 1, meaning this number here. So is 0 not equal to 0? Well, they are equal, so we are not gonna enter this if statement, and we're gonna move on to the next round, because this condition was not true. In the next round, which is gonna be the second round of our for loop, our I has been incremented because of the for loop, and now I is pointing to the number with the index of 2, which is this number here. So now we're gonna ask if numbers of I is not equal to numbers of I minus 1. So numbers of I is gonna be 1. As you can see, it's 1. And then the number before it is gonna be the 0. So is 1 not equal to 0? Well, they're not equal. So we're gonna enter this if statement, and we're gonna say the number at the index of k, meaning the number inside of our numbers array at the index of 1, should be equal to 1. And this is the number with the index of 1. So the 0 has to be 1 because we just said this should be equal to 1. And then after we're done with this, we're gonna increment our k. So k is gonna become 2, and then we're gonna enter our third round. In our next round, our I is gonna be 3, so it's gonna be pointing to this number, and we're gonna check if numbers of I, which is 1, is not equal to numbers of I minus 1. Well, as you can see, 1 is equal to 1, so we're not going to enter this if statement, and we're going to enter our fourth round. In our fourth round, our I is going to be equal to 4, so it's going to be pointing to this number here. So is numbers of I, which is 1, as you can see, it's 1, not equal to numbers of I minus 1, which is this number here. So is 1 not equal to 1? Well, they are equal, so we're not going to enter this if statement, and we're going to ignore all of these, and we're going to move on to the next round. In our fifth round, our I is going to be 5, so it's going to be pointing to this number here. So numbers of I is 2, and numbers of I minus 1 is going to be 1. So is 2 not equal to 1? Well, this is true. So we're going to enter this if statement, and we're going to say the number at the k index, meaning the number at the index of 2, should be equal to nums of I. This is the number with the index of 2, so this has to be 2. And as you can see, we've actually changed it because we assigned this number to 2. And then we're going to increment our k. Then we're going to enter the sixth round. In our sixth round, our I is going to be 6, so it's going to be pointing to this number. So numbers of I, which is 2, not equal to 2 because this is the number before it. So is 2 not equal to 2? Well, they are equal. So we're not going to enter this if statement, and we're going to move on to the seventh round. In the seventh round, our I is going to be 7. So it's going to be pointing to this number here because this is the number with the index of 7. So numbers of I is going to be 3, and numbers of I minus 1 is going to be 2, as you can see here. So is 3 not equal to 2? Well, this is correct. So we're going to enter this if statement, and we're going to say the number at the index of k, meaning the number at the index of 3, should be equal to 3. So let's do that. This is the number with the index of 3, and this has to be 3 because we just assigned it here, and then we're going to increment our k like so, and then we're going to move on to the next round. In this round, our I is going to be 8, so it's going to be pointing to this number. So numbers of I is going to be 3, and numbers of I minus 1 is going to be 3 as well. So this is not going to be true, and we're going to move on to the ninth round. In our ninth round, our I is going to be pointing to this number because it's equal to 9. So numbers of I is going to be 4. And the number before it is going to be 3. So is 4 not equal to 3? Well, this is entirely correct. So we're going to enter this if statement, and we're going to say the number at the k index should be equal to numbers of I. So the number at the fourth index should be equal to 4. So let's do that. As you can see, we just changed it. And then after that, we're going to increment our k. And then we're going to move on to the next round. But as you can see, we're done looping. So we're going to exit our loop, and we're going to return our k like so. As you can see, k is equal to 5, and we have 1, 2, 3, 4, 5 unique numbers. Now you might say we still have duplicates here. Well, you are completely right, but the question itself says that it's going to check our array for duplicates until the k index. So if we give this to the question and actually submit it, it's going to check until here, and as you can see, until this part, we don't have any duplicates. So now let's code this in the simplest way possible. Alrighty, so first of all, we're going to define our k variable just like we saw in the slides, and this is going to be equal to 1, and then below it, we're going to define our for loop. Again, just like we saw on the slides. So for let I be equal to 1, not 0. And we want to keep on looping as long as I is less than numbers.length. And we want to increment I on each round. And here we're going to enter our for loop. And we're going to have our if statement. And we're going to say if numbers of I is not equal to numbers of I minus 1. So meaning if the current number is not equal to the previous number, meaning we have a unique number, do the following. We're going to say numbers at the k index should be equal to numbers of I, and then below it, we're going to increment our k, and this is it. At the end, we're going to return our k. This is all of our code. Now let's run it and see if we're going to pass our tests. Yep, as you can see, they're all passed. Now let's submit it. Moment of truth. Let's see what's going to happen. And as you can see, it's submitted, and we're beating 94% of all of the other submissions. That's awesome. Let's analyze our time complexity. It's going to be n because we only have one for loop, as you can see. Alrighty, thanks for watching. Don't forget to like and subscribe, and keep on coding.